Grounding to 200 amp service panels with shared ground rods is permissible, provided certain requirements and procedures are followed. Firstly, the ground rods must be at least 8 feet long and constructed of copper-clad steel or stainless steel. Secondly, the ground rod conductors must be insulated copper wire or bare copper wire size according to the National Electrical Code, or NEC. Thirdly, the ground rod conductors must be securely attached to the ground rods using grounding clamps. To proceed, follow these steps. 1. Drive 2 ground rods into the earth, ensuring they are at least 8 feet apart. 2. Attach grounding clamps to the ground rods. 3. Run separate ground rod conductors from each grounding clamp to the main grounding busbar in each of the electrical service panels. 4. Ground the neutral conductor of the electrical service at the service entrance. 5. Connect the ground rods with a grounding conductor, typically number 6 American wire gauge or AWG copper wire, to ensure the ground rods are bonded together. Using the same 2 ground rods helps to reduce material and labor expenses. Bonding the ground rods provides a low resistance pathway to earth for fault currents and lightning strikes. Correct grounding safeguards individuals and equipment from electrical shock and harm. Remember that some electrical regulations may mandate further bonding or grounding measures. Always refer to the local electrical code and seek advice from a certified electrician for detailed specifications. Grounding is a critical aspect of electrical safety. It provides a path for fault current to return to the source, tripping a circuit breaker or fuse and energizing the circuit. This prevents electrical shock and minimizes the risk of fire. The NEC provides detailed requirements for grounding electrical systems. It covers topics such as the size and type of grounding conductors, the methods for connecting grounding conductors to ground rods and other grounding electrodes, and the requirements for grounding different types of equipment. Ground rods are a common type of grounding electrode. They are typically made of copper-clad steel or stainless steel and are driven into the earth to provide a connection to ground. The NEC requires that ground rods be at least 8 feet long and that they be installed at least 8 feet apart. The size of the ground rod conductor is determined by the size of the service entrance conductors. The NEC provides a table that specifies the minimum size of the ground rod conductor for different sizes of service entrance conductors. The ground rod conductor must be connected to the ground rod using a grounding clamp. The grounding clamp must be listed for the purpose and must be properly installed. In addition to ground rods, other types of grounding electrodes can be used, such as metal water pipes, metal building frames, and concrete encased electrodes. The NEC provides specific requirements for each type of grounding electrode. Grounding the neutral conductor of the electrical service at the service entrance is another important aspect of grounding. This provides a path for fault current to return to the source, even if the ground rod connection is lost. The NEC requires that the neutral conductor be grounded at the service entrance using a grounding electrode conductor. The grounding electrode conductor must be sized according to the NEC and must be connected to the neutral conductor using a grounding clamp. Bonding the ground rods together is also important. This ensures that the ground rods are at the same potential, which reduces the risk of electrical shock. The NEC requires that ground rods be bonded together using a grounding conductor. The grounding conductor must be sized according to the NEC and must be connected to the ground rods using grounding clamps. Proper grounding is essential for electrical safety. It protects people and equipment from electrical shock and minimizes the risk of fire. Always follow the NEC requirements for grounding electrical systems and consult with a qualified electrician if you have any questions. Additional bonding or grounding measures may be required depending on the specific application and local electrical codes. For example, in some areas, it may be required to bond metal water pipes and gas pipes to the grounding system. This helps to ensure that these metal objects are at the same potential as the grounding system, which reduces the risk of electrical shock. It is also important to ensure that all electrical equipment is properly grounded. This includes appliances, tools, and other electrical devices. Grounding electrical equipment provides a path for fault current to return to the source, which helps to protect people from electrical shock. The NEC provides specific requirements for grounding different types of electrical equipment. Always follow these requirements and consult with a qualified electrician if you have any questions. Grounding is a complex topic, and it is important to understand the requirements of the NEC and local electrical codes. Always consult with a qualified electrician if you have any questions or concerns about grounding electrical systems. The importance of proper grounding cannot be overstated. It is a critical safety measure that protects people and equipment from electrical hazards. By following the NEC requirements for grounding and consulting with a qualified electrician, you can help to ensure that your electrical system is safe and reliable. Always remember to disconnect power before working on any electrical equipment. Use appropriate safety gear such as insulated gloves and safety glasses. Test circuits to ensure they're de-energized before working on them. If you are not comfortable working on electrical equipment, contact a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself from electrical shock and other hazards. The use of 2 ground rods, as described, enhances the effectiveness of the grounding system. If one ground rod becomes compromised due to soil conditions or corrosion, the second ground rod provides redundancy and ensures that a low impedance path to ground is maintained. This is particularly important in areas with high soil resistivity or where lightning strikes are common. The selection of appropriate grounding clamps is also crucial. Grounding clamps must be made of corrosion-resistant materials and must be properly sized for the ground rod and grounding conductor. The clamps must also be installed tightly to ensure a good electrical connection. Periodic inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Ground rods and grounding conductors should be inspected for corrosion and damage. Grounding clamps should be checked for tightness. If any problems are found, they should be corrected immediately. Grounding is a fundamental safety practice that protects individuals and equipment from electrical hazards. It is essential to understand the principles of grounding and to follow the requirements of the NEC and local electrical codes. By doing so, you can help to ensure that your electrical system is safe and reliable. Grounding electrode conductors, often made of copper, connect the grounding electrode, such as the ground rod, to the equipment grounding busbar within the service panel. Their size is determined by NEC Table 250.66. Based on the size of the ungrounded service entrance conductors. A common misconception is that grounding conductors carry current during normal operation. In reality, they only carry current during a fault condition, providing a low impedance path for the fault current to return to the source and trap the overcurrent protective device, like a circuit breaker. The term ground itself refers to the earth, which serves as a reference point of zero potential. Grounding systems are designed to maintain a stable voltage relative to ground, preventing dangerous voltage buildup that could lead to electrical shock. The Earth's conductivity varies depending on soil composition and moisture content. Therefore, using multiple ground rods, as described in the procedure, helps to reduce the overall resistance of the grounding system. This is especially important in areas with dry or rocky soil, which tend to have higher resistance. In addition to grounding rods, other types of grounding electrodes include metal underground water pipes that are in direct contact with the earth for at least 10 feet, the metal frame of a building if it is effectively grounded, and concrete encased electrodes, also known as UFA grounds, which consist of a bare copper conductor encased in concrete that is in direct contact with the earth. The selection of the appropriate grounding electrode depends on site conditions and local code requirements. When connecting the grounding conductor to the ground rod, it is essential to use a listed grounding clamp that is compatible with both the conductor material and the ground rod material. Using dissimilar metals can lead to corrosion and a poor connection, compromising the effectiveness of the grounding system. The grounding system should be installed in a manner that protects it from physical damage. Ground rods should be driven into the earth to a sufficient depth to prevent them from being easily disturbed. Grounding conductors should be routed in a way that minimizes the risk of damage from digging or other activities. Regular inspection and testing of the grounding system are crucial to ensure its continued effectiveness. A ground resistance tester can be used to measure the resistance of the grounding system to earth. The measured resistance should be below a certain threshold, as specified by the NEC and local codes. If the resistance is too high, it indicates a problem with the grounding system that needs to be addressed. Grounding is not the same as bonding. Grounding connects the electrical system to the earth, while bonding connects different metal parts of the electrical system together to ensure that they are at the same potential. Bonding helps to prevent dangerous voltage differences between metal parts that could lead to electrical shock. The NEC requires that all metal parts that are likely to become energized be bonded together, including metal enclosures, conduits, and equipment frames. The bonding conductors must be sized according to the NEC and must be connected to the metal parts using listed bonding connectors. In addition to the grounding and bonding requirements for the electrical system, there are also specific requirements for grounding and bonding sensitive electronic equipment, such as computers and communication equipment. These requirements are designed to protect the equipment from damage due to voltage surges and other electrical disturbances. The NEC provides guidance on grounding and bonding sensitive electronic equipment in Article 250. The grounding system is an essential part of the electrical system, and it is important to ensure that it is properly installed and maintained. By following the requirements of the NEC and local electrical codes, you can help to protect yourself and others from electrical hazards. It's worth reiterating the importance of consulting local electrical codes and a qualified electrician for specific requirements in your area. The electrical codes can vary depending on the jurisdiction, and a qualified electrician will be familiar with the specific requirements in your area and can ensure that your electrical system is installed safely and correctly. Always prioritize safety when working with electricity. Never work on electrical equipment unless you are qualified to do so. If you are not comfortable working on electrical equipment, contact a qualified electrician. Electricity can be dangerous, and it is important to take the necessary precautions to protect yourself from electrical shock and other hazards. Finally, understanding the purpose and function of each component within a grounding system contributes to a safer and more informed approach to electrical work. From selecting appropriate ground rods and conductors to ensuring proper bonding and regular inspections, every step plays a vital role in maintaining a reliable and safe electrical installation. Remember to consult the latest edition of the National Electrical Code and local amendments for the most up-to-date requirements.